Hello, today we're going to look at a demonstration of the LDL actuator from SMAC against a pneumatic solution and see how they both respond. I'm joined today by Romain and Girard of SMAC, and we're going to spend a little bit of time looking at the LDL actuator and how it responds in relation to a pneumatic solution. Hello, Romain.
Hi, Tony.
Perhaps you could start by explaining what equipment we've got in front of us.
Yeah, sure. So on that demo kit, we have on this side the pneumatic solution. You have your pneumatic cylinder with the two limit switches to get that position feedback. It's a pure bang-bang solution.
Yeah.
All the pipes that goes around to get your valve and solenoid for the control.
Okay.
And what you can't see from here is compressor and all the prep work for the air. So filter, regulator and
Lubricator.
Lubricator, exactly. So you really need all that equipment to get that little thing working here.
Yeah, because you've got to prep the air. Yeah.
Exactly.
Okay.
On the other end, you've got an LDL, 25, 50 millimeter stroke actuator with a built-in controller at the back.
Yeah.
So that is a ready-to-go solution.
A self-contained unit.
Exactly.
Okay. There's no other elements required except for an input to take it to move.
Exactly.
Yeah.
That.
Okay.
Yeah. And then we have a screen at the back just to have a bit of display of what's happening during the demo.
Okay. Can you show us the demo running then?
Yeah, sure. So we're going to start with a cycle where we're going to run both solutions simultaneously.
Yeah.
And we can see how they compare on one cycle.
Well, that was quick. Can you explain what actually happened there?
Yes, so both units were running a 12 millimeter stroke actuation. So this cylinder is 12 millimeter, so that's all you're going to get from it.
Yep.
Where this one is 50 millimeter.
Okay.
But you can actually select whichever position you want.
So you can stop it any way you like?
Exactly.
Okay.
So we have set it to 12 millimeter, so we can compare the same movement between
a like-for-like move, yeah?
Exactly. So now if we look at the screen, we've actually had the feedback of how long it takes for each solution to perform the motion.
Okay, so what's it say on there? It says 19 milliseconds for the LDL and 60 milliseconds for the air.
Exactly.
So it's nearly 3 times as fast then.
It is 3 times as fast.
Yeah.
Exactly. And you can see that on the frequency as well. You could go up to 52 hertz on that solution, where you would be limited to 16 hertz on the pneumatic.
Okay. Okay. I heard a lot of noise there. Where's the noise coming from?
So we can run a second demo to check that and really compare each solution on 5 cycles.
Yeah. Okay.
So we're gonna run that second test.
Yeah. Okay. I can obviously differentiate that the noise is coming from here.
Exactly.
Okay. So that's basically due to the fact that this is hitting the end stops on the pneumatic actuator. That noise is being generated.
Exactly. You're not controlling the position.
Yeah.
You go to the bang and you go back to the other bang.
Okay.
And you can't control and have any adjustments and any reduction in noise. You could, but you start going into dampers and a lot of complication in the actuators.
So obviously one advantage is the fact that there's much less noise coming from the LDL.
Yes.
Are there any other advantages we can actually say about this solution in relation to this solution?
Yeah, so still about the noise, you can talk about leaks.
Yeah.
Leaks is also a noise always in the background.
Yeah.
It's not really nice
It's
to hear.
efficiency as well.
Exactly. So leaks would also cost you money because you need to keep that pressure all the time. And also the fact that compressed air is the most expensive energy to use in a company. Now switching to electric, it's a huge saving. Not only on the air, but all the piping and all the maintenance of that equipment.
And you've got your filters, regulators and lubricators to prep all your air as well.
Exactly.
Which you can do away with in this solution.
Yes, yeah. So another advantage is the reliability of the LDL actuators. You're going to be talking about 10 million cycles on a pneumatic cylinder. You would do over 100 million cycles on an LDL solution.
So the life expectancy of this product is much higher than the life expectancy of the actuator here?
Yes, more than 10 times.
Okay.
So you're now comparing one actuator here against 10 actuators here with all the downtime that comes with changing those products.
And you've got a fixed stroke on here, whereas this one has a variable stroke, so you can virtually stop anywhere you like?
Exactly. And you can change that in literally seconds from your PLC or from your program that you have on your either on the controller or on the PLC. A really simple input can change that for different products.
And if you want to control the speed of operation of this, can you change the speed as well, which you couldn't do on here?
Yes, it's fully programmable, so you can change the position, the speed, the acceleration, and the force at any time.
Obviously, as a like-for-like system, is this more expensive than this, or are they comparable? How do we define the two?
So that's where it becomes a bit tricky to compare, because you're not comparing like for like.
Yeah.
If you compare the cost of purely that cylinder to that LDL, yes, the LDL is going to be more expensive. But you're not just buying something to do a motion.
No.
You're buying the system. So you get, by buying an LDL, you don't need the solenoid, you don't need the valve, you don't need your compressor, you don't need all that prep for the air.
Yeah.
So it's all this that needs to be considered, and the reliability of that unit.
And you get all the extra features in.
Exactly.
The ability to position to virtually infinite positioning within the stroke.
Yes.
And also control velocity and acceleration.
Yes.
And force.
Exactly. And the speed of the system. So now if we look at the time to perform the 5 cycles, it took 120 milliseconds for the LDL to do 5 cycles.
Yeah.
It took 224 milliseconds for the pneumatic solution.
So a lot faster, nearly 100 milliseconds faster then?
Yes. Yeah.
Okay, that's impressive.
So the customer can increase
His throughput.
his throughput.
Yeah, okay.
While having longer reliability.
Yeah, that's good. That's good. Thank you for taking the time to explain all that to us,
Thank you.
Romain. Thank you for watching. I hope you found that useful. If you've got any questions, please feel free to contact us. Thank you for your time.